Thank you for being on the call. We struck up a good conversation at PERC over the summer, and we asked you to come on today to kind of talk about Globus and on the researcher-facing track. So thank you for being here today, and I will go ahead and stop the sharing of my screen, and you should be clear now to go ahead.
Great, thank you. Thanks, Justin, and thanks everybody for hosting us. Can everybody see my slides okay?
Yeah, it's looking good.
Okay, good. So one thing I wanted to start out by saying, because I know we get this question a lot, is Globus a vendor? And we've had questions about vendors presenting at these kinds of forums. I want to assure you that we are the University of Chicago. We are actually a department in the VP of Research office, and we operate the Globus service as something for the community, and we do so in a sustainable way. So that's where there's a sort of a little bit of a vendor angle, and if anything, we act like a vendor in many cases because we are delivering a production grade service that many hundreds of thousands of researchers are relying on. So that's just a little bit of context on the organization and where we fit within the university. So the topic today is talking about automation and remote computation. And I want to use a specific scenario, a class of scenarios centered around instrument data, because this is really what we're seeing as driving much of the growth in usage of Globus, not just Globus, but really all sorts of data management technologies and processing technologies. So if you're anything like some of the typical campuses that we work with, you've got research cores that provide different facilities. You've got high performance computing, storage of different types. You are hopefully being driven at least not just by the funders, but by sort of good science to describe your data, put it through some sort of curation, and put it out there for more easy access, make it more fair, so that people can get to it. And so all of these aspects of the sort of the data processing or data management life cycle are things that we try and make more efficient in some ways, wherever we can. So some of the things that we've identified as being almost table stakes for doing this right, at least from our perspective, is the first thing is really being able to have access to all your data irrespective of where it lives. So that's an area where we spent the bulk of our time since the Globus service was launched in 2010. We've spent a lot of time there. What's becoming and has been for a couple of years now really critical is policy enforcement, especially with different compliance regimes. So we've really spent, we've made a large investment in ensuring that. You also want to be able to give the PI, give the researcher autonomy over their data where it makes sense, and allow them to analyze it wherever they have access, not force them through specific resources or specific constraints to use just this type of computing or just that. Being able to apply best practices across the pipeline, ultimately getting hopefully to data fairness. And there's probably a whole bunch of other things that I'm not mentioning that are important, but these are the areas certainly that we have some influence on, if you will. So I'm actually going to use an example like this to illustrate what I'm going to be talking about. So this is fairly representative of the types of things that people are doing on campuses when it comes to working with instrument data. And you need to have some level of automation, at least that's what I'm positing here, because of the scale of the data and because of the fact that you have these expensive shared resources within the various cores and other places that need to stay utilized. So being able to take data off an instrument, do some analysis on it, put it somewhere else, make it available to others, perhaps, hopefully, extract some metadata, push that data into some type of index, clean up after yourself, if you will, and ultimately make the data available and make it, as we like to say, fair by default. So if you can sort of aspire to having automation in place that gets you to this fair by default nirvana, that's really what we try and help you do. So I'm actually going to start with a demonstration. I kind of grappled with this because this is something we're actually building to show at our booth at Supercomputing next week. And I thought, why not do a trial run here? I mean, after all, live demos, what can go wrong, right? So I'm actually going to switch over to my a Windows VM because I'm going to pretend we're actually in a microscopy core. The campus core wouldn't let me take the Zeiss confocal microscope, so instead I bought one of these. I don't know if you can see it, but it's a $20 magnification device which will serve as a microscope. So here I am pointing it at a sample. Not very exciting. I'm not sure what tissue this is, but it is some type of animal tissue. So what we'd like to get to, at least what we hope many folks aspire to do, is get to a point where from the time that data is generated, be it on a microscope or be it anywhere in whatever context, to the point where it's, if you will, published or available for others to consume and work with downstream, that whole process is automated. So I'm going to demonstrate that by literally just clicking the capture image button. So it's going to capture an image. You'll see it showing up here on the local microscope. And I'm hoping that a flow was started, and I'm going to talk about what all of these pieces are. So what happened was the image was captured, something was tracking that and started this automated process to get the data out to somewhere where it's more easily accessible by others. So if I look at my microscope here on the left, that's the image that was generated, and out here it should end up in a repository, and it's going to be under the SC folder here. Oh, didn't realize I've got so many of these. So yeah, so this is actually the image that was created, and it actually went through that whole flow that I was showing earlier. So it was processed. Metadata was extracted, put into an index, and then the image was made available. The image and its results. And by the way, the results, in case you're wondering, were very sophisticated analysis that generated a thumbnail of that image, but good enough for our illustration purposes. So, so that whole process really is automated by some of the services that we have in the Globus platform. So I recognize a lot of names when I was just scanning the attendee list. So it's nice to see everybody here again. For those not familiar, Globus has a number of capabilities, starting out with being able to manage file transfers reliably, share data, make data accessible in all types of storage, etc. But really today I'm going to focus on two of the services here in the middle, our sort of higher value services, if you will, which are the remote computation and the automation, which we just saw in action. And by the way, as I go along here, I can't see the chat or the hands, but if you have a question, please just unmute. I don't know what the normal protocol is, but I'm happy to take questions as I go along here.
Yeah, great, Vas. I put that in the chat that folks should feel free just raise your hand or use the chat, and I can interject, or you can do the same. So thanks, Vas.
Okay. Okay, so I'm going to talk about the service called Globus Compute first, which is our federated FaaS service, and I want to start out just providing a little bit of context because some years ago we started rethinking the way research computing is done, and what drove that was three different dimensions. The one is the nature of the resources that are being used. It used to be that you had a cluster and that was research computing, right, in a nutshell. Obviously, that landscape has become much more diverse, not just GPUs and things like that, but really specific types of devices, capability class machines in national supercomputing centers and so on. So the fact is these resources are increasingly distributed because you can't have all these specialized resources everywhere, obviously. the nature of the workloads has changed dramatically. Need I say AI? I haven't said it. Yes, I'll say it now, and I hopefully won't say it again for the remainder of the talk. But all the different usage modalities and the users themselves. So this is really the part that strikes home for me, because I grew up in a world where the command line was the interface, and a lot of stuff was handcrafted. We're in a very different world with much more interactive computing, with front ends like Jupyter Notebooks and so on. And we're having people coming to research computing from all academic disciplines. It used to be really much more the purview of, if you will, the hard sciences, physics, etc. But that's no longer the case. Hopefully you're seeing that in your respective campuses. Yeah. So people with different backgrounds and different ways of working. So we really felt like we need to break out of this mold of thinking about research computing as a cluster that you submit batch jobs to.
Yeah. Vas, I just want, you can answer this as you go when you're there, but a question just came up about where does the computation run, and is it suitable for sensitive data? So if you can address that.
Absolutely. I will talk to where it runs in a second. I will say that right now our compute service is not certified for sensitive data, but that is if not the top, probably the second item on our priority list that we're working through. So it soon will be, and we do have a model where you can manage protected data, and we can sign BAAs if you are working with PHI and so on. So that is a work in progress. So what we came up with was sort of borrowing from a few aspects. One is saying when a researcher is doing some analysis, what's the natural way of thinking about it? One way is to think about the things I'm going to run as functions. I'm going to operate on this data, put it through a pipeline, certain functions. So that sort of started us thinking about this function as a service approach. The other one is we, sort of learning from what we did on the file transfer world. We have this fire and forget reliable file transfer. Well, can we do the same thing in computation? Can you fire and forget a compute job and just let it do its own thing, irrespective of what the background environment looks like? Is it a Slurm resource manager? Is it a Kubernetes cluster running somewhere in the cloud, or something in between? Not having to be aware, if you will, have all those details and nuances of those environments abstracted away, and just be able to access them programmatically and say, just run this piece of code over there. And again, providing a consistent interface all the way, as we say, from the edge to the supercomputer, any type of device. And I'm showing some examples here. And we have experience with a number of different environments, and happy to dive into those in more detail. So what the service comprises are three things. So there's the service itself. This is what we host. It's sort of the orchestration engine, if you will, that manages all the different bits. If your researchers wanted to use this, you would deploy, or they would deploy, what we call a compute endpoint. So that's software that you deploy locally, that can be deployed on your cluster. It can be deployed on any environment where the researcher has access to compute resources. And then because this is all programmatic, there's an SDK that allows you or the researcher to weave this mechanism into the way that they do their analysis. So instead of doing an S run, they can say, Python function run XYZ, and off we go. So this is really what it looks like visually. I have a piece of code as a researcher. I register it with the Globus Compute service. And when I say a piece of code, it can be a substantial code base that's containerized, so that there's, with the environment and so on. And then I can come along and say, hey, Globus Compute, please run this piece of code on resource A or resource B, or both, right? If I'm perhaps running one type of code on a different class of machine versus another, I have the same interface, and Globus will manage the whole process of putting the code down on those resources, creating the environment, running the code, shutting everything down, getting the data back out, You could have that be done sort of synchronously. Even though everything works asynchronously, you could sort of wait for data to get back to you, or the data can be put somewhere where you can go and retrieve it later, which is actually what I have in the in that little example, which I'll show you. I'll show you what's behind the scenes on that simple point and click exercise in just a little bit. So that's, again, at a very high level, what it looks like. I'm actually seeing a question here. Do we support standard bioinformatics in NetFlow, WDL? So right now, I'm going to talk to the Flow service in a second. It doesn't support that natively, but there's no reason why you can't call out and run a specific bioinformatics pipeline with your variant calling and then other things, let's say if you're doing sequencing, what have you. So just on a little bit more on the technical side, so that you're aware of what this looks like. What you do on your resources is install this Globus Compute agent. It's a pip installable piece of code, and it actually supports many of the environments that are commonly deployed at research computing and advanced computing centers. You can see some of them listed down the bottom here, Slurm, etc. And this is an architecture slide, which I'm not going to spend time on. The main thing I want to point out is that there are two environments: the Globus Compute environment that we maintain, and then this is the local environment, if you will, on your system. We have a capability to run the endpoint as a single user or as a multi-user endpoint, where each user comes along, talks to the same endpoint, and then gets their own little sub-process that executes their function. I'm happy to dive into the architecture to the degree I can if we have time later on, but I'll just put that up there sort of for later reference. So that's the Globus Compute service in a nutshell. So that, in combination with all the other services that we have in Globus, to bring all those things together, we developed this thing called Globus Flows. So Globus Flows is another way of sort of reliably managing a sequence of tasks. So the same way we have reliable management of a file transfer task and now a computation task, now we can string these things together, tasks of various types, and sort of outsource the management of that pipeline, if you will, or that flow, as we call it, to the Globus service. So when we talk about a flow, it has a series of what we call actions. You see a sort of a stereotypical example along the bottom here. And for every action, there is a corresponding what we call an action provider, so the interface, the service that gets called to perform that specific task. So when you have a transfer action, it calls out to the Globus transfer action provider. And this is actually an extensible model. If you wanted to call out to services of your own, you can easily weave those into the flow by extending this action provider model. So how does this look from the perspective of someone who wants to use it? So what you have to do first off is define a flow. And if you're scared by looking at this JSON, don't be. I'll tell you why in just a second. You define the flow, you deploy that within the Globus service. So you tell Globus, hey, here's a new flow that I would like to run. You also have, this is a nascent tool that we have that creates more of a visual view of the flow. So it's a little bit easier to envisage and debug and define. Once the flow is registered, you can decide who has access to it, who can run it, who can administer it, who can monitor the runs, and so on. So this uses our underlying security model called Globus Auth. You'll typically, might run it a few times. Like I've probably run my supercomputing flow about 60 times over the last couple of days, trying to get it debugged. But now I think it's pretty stable. It seemed to work. And once it's in place, then you can literally hit the button and have it run over and over repeatedly. I'll show you some examples of where we've done this at scale later on. So the separation of duties here fairly typically is that someone in the research computing world, the research computing facilitator, or someone of that ilk will work with the PI to understand what they need, what their flow looks like, implement it for them or help them implement it, depending on sort of the skill set and backgrounds. And then once it's in place, it's really, the PI should be able to just take it on and run it. They can delegate access to others in their group, in their lab, their postdocs, and so on, so they can run it without them, and any number of other access models as well that we support. So as I said, if you're a little concerned about having to write JSON stuff, don't be. We have a number of examples in our documentation as well as in some other repositories. And if you're not seeing, if you don't see something that you like there, we're more than happy to help you develop these flows. We've invested a lot in this service, and we are very motivated to help people adopt it more widely. We've got a number of large-scale users, but we're always looking for more, and we're happy to invest our time in helping you do that. We also have, so what you saw me do there earlier in that simple demo was drop a file. Essentially, the microscope captured an image, that file dropped, and it actually triggered that flow. So there is also a capability to trigger these flows based on events happening on the instrument, on the file system. We've got some rudimentary scripts that can serve as a starting point for that. Again, we're happy to help you extend those, build additional ones, and so on. We have a group that literally does that all the time for folks out there. See another question. Can you speak to Globus integration with public cloud services related to serverless functions, compute provisioning, and budget quota management? Okay, that's a very broad question. I can speak to, so as far as serverless, so our Globus Compute service, the way I like to sort of trivially characterize it is, it's like Lambda for any compute resource, if you're familiar with Amazon Lambda, or with Google Functions. It's like Google Functions on any, not just on Google, right? So in that sense, it's the same model architecturally. It's function as a service. So it's serverless in the sense that the researcher or the PI doesn't need to go and provision their infrastructure, but you've got to have some compute behind it, as Amazon and Google and others do in the cloud. So if that's an on-prem deployment, you set that up, you set up the compute agent, and at that point, it becomes the same model of just calling out and invoking a function. As far as the compute provisioning, that's built into the configuration, so that is automated, and you have a lot of different knobs and levers that you can pull to define what the environment looks like, what resources should be made available, over what timeframes, all the kinds of things that you might typically specify if you were in a more classical resource scheduling environment. All those capabilities are still available to you, but now you can provide this templated configuration so that users, perhaps with different types of workloads, can just show up and say, run this in this environment, and it'll provision everything, it'll scale it up, it'll scale it down when it's done. So that's all there. Budget and quota management is not something that we've sort of dabbled in at this point. We have these capabilities out there. We're assuming that you will be, monitoring budgets and usage and allocations the way you usually do. This is just another consumption modality, if you will, for that same resource. And whatever you have in place right now, I think you should still see the same level of activity. We haven't exposed any of that in our service at this point. Any other questions? No. Okay. So having described some of those services in a bit more detail, I'll go back to the example that you just saw, that little demonstration that I just did. So what I actually have there, you saw my Windows VM. So I have a Windows machine, which is, again, for those that have worked with instruments, it's pretty much the norm, is that you have Windows machines, some cases really old ones. I will say we are still seeing Windows XP out in the wild. You may be too. Mine was Windows 11, just to be safe. So what I have on that instrument is I'm running one of these trigger scripts that's monitoring the directory that the microscope is putting images into. So that monitor script is looking for files that show up. When a file shows up, it triggers that Globus flow. And that flow has 7 steps in it. The first is it moves the data. In this case, it actually moves it to an EC2 instance, an Amazon EC2 VM, where the code runs. So the next step is to actually invoke Globus Compute. So I've registered a function that does that simple analysis of generating a thumbnail. And the compute endpoint calls out to Globus Compute, says, you have some work for me. It takes that job, if you will, runs it, generates the results. And then the next step in the flow is to move those results out to a storage system that's a little more broadly accessible. And then in order to make the data available to some additional set of people, the flow sets permissions. In this case, I'm sharing it with a group of users that I've defined within the Globus service. So this might be my lab, my project team, my collaborators at other institutions on this grant, and so on. And then there are 2 steps where I'm actually ingesting metadata. You may ask, why 2 steps? Well, I actually have 2 steps because I want to demonstrate our search service, which allows you to ingest metadata with different levels of visibility. So my first step 5 ingests some open metadata that anybody who has access to that index can search on. And then 6 actually has some protected metadata, so that only people or a group of people that I specifically grant access to can see the metadata. So the data is still there and searchable, but just that metadata doesn't show up and isn't included in their search because it may contain sensitive data. So the 5 and 6 are ingesting into the search index, and then 7 is just doing a little bit of cleanup of the scratch space so that we don't chew up all that local disk. And then we've got this data that's available for people to come and query. So if I go back to my Windows, oops, that's the wrong page. If I go back here to my Windows machine, don't know if you can see this, but I'm just going to run the Globus command line. That's another way to interface with the Globus service. I'm going to actually run a search. So I'm going to query all things that are relating to possums, because I've got possums and mice and different samples coming in here. So when I run that query, it actually queries the index that I just put the data into, and it gives me back the results. I've limited to 5 results. I think I've got about 40 or 50 entries in there at this point. But this is just an example of the metadata. And this is metadata that I specifically defined for this index, for this project. So if you do end up using a service like Globus Search to do this, you can define your own metadata schema. So you can see this has some details about the microscope and the experiment itself, some of the parameters of the experiment, some details on the sample. And then the second little subset of data down the bottom here on the bottom left has the protected data. So it's got some compounds, lifespan, specific age, I just made up some stuff that might sound interesting to some. And then ultimately it points to the data in the subject. And so again, there's a whole bunch of these that came back, but that's where the data ended up. So just sort of to recap, we started out taking a picture, and I can just take another one. Whoops, I don't know if you heard that, but pretty loud. And this runs another flow. So shortly here, it'll go through that entire flow and see, and we'll see the results here. And if you want to see what that flow looks like while it's running, this is the one that's just ran. So it started, and you'll see each of the 7 steps that I was describing reflected here in the event log. So we've moved the raw data. Now the processing is happening. That was very quick. We've moved the data out to this large repository out in Argonne. I'm sharing the results now, and then you'll see the index ingesting, and now I'm doing the cleanup. And then, so in fact, if I go back to my file manager and I refresh that, I should actually see, let's see, I should actually see that second sample show up. So that's sort of it in a nutshell. I have a couple of examples. I see a question: is flows on the roadmap for inclusion in the high assurance? Yes, absolutely. Just the same way that compute is being made high assurance capable, for use with protected data, so is Flows. And I should mention that even though I've showed a completely sort of turnkey automation end-to-end example here, the service does allow a human in the loop at various stages. So in cryo-electron microscopy, which is another big area of application for us, you typically have the scientist in the middle using one of the common tools to work with the images, to get alignment, orientation, etc., other things, resolutions, whatever. So you can have that in the loop, and you can have these flows run with human actions in the middle, and then continuing with automated actions. So I wanted to sort of close out by talking about some additional examples of what this looks like when you get to really large scale. And this is sort of our canonical example. It's our largest deployment. It's at the Argon photon source. So the advanced photon source at Argon, the APS. And so this is basically a very bright X-ray, which just was upgraded. So it's going to have 500 times, I think, the resolution of the brightness. So the data is going to be orders of magnitude greater. And you can see here in all the different beam lines, it's a very busy slide, but each of the little blue dots is a deployment of the Globus Connect storage, the data software. And then the little orange bubbles are the Globus Compute. So some of them actually have local computation. You can see on the bottom here, the Orthos cluster and the APS DM system. So some of the beam lines, when the data comes off the instrument, they will do some local computation, and then they'll push the data out to the leadership computing facility to use a more advanced machine like Theta or Polaris or one of the other big systems. Again, they could have just as easily pushed it out to their campus cluster and run some jobs. And so they've got this running at scale. I'm going to skip the slide. It has more detail. I put it here just so that you have a reference to a paper that you can go and read up if you want to learn more about this. This paper was published by Raf Vescovi and many other collaborators about a year and a half or two ago. But it sort of codifies a lot of the work that was done here early on, and we've since evolved it. And so we have these variations of the same type of pipeline with multiple data and computation steps. And they actually, in the case of the APS example, they actually, the data ends up in a repository that's accessible by, in some cases, it's a public repository. In others, it's restricted just to the people on that experiment. This just gives you an idea of the scale of the runs over the last couple of years. This stops in 22 because that's when the facility went down for the upgrade, and it's going to pick up again. So we've started running some initial loads again, but there are literally tens of thousands of runs. This is just a screenshot of that same team that was running these back in the day. You can see they had 45,000 odd runs. And again, these are all completely automated. Once those samples get plugged into the instrument, some number of hours later, and it's hours because there's some advanced analysis going on here, some number of hours later, you'll actually see data show up in the data portal. And if you wanted to go look at some of this, there is actually a public repository. This is the URL, ACDC, the ALCF Community Data Co-op, and it's at the Argonne Leadership Computing Facility at argonnationallab.gov. So lots of acronyms there. I will be sharing these slides so you can go check that out if you like. So I think that's really all I had as far as content. I will mention, again, I want to just briefly talk about our sustainability model, because one of the reasons why we think we've had some impact and a lot of researchers with their work is because we've thought about sustainability from the get-go. So we have this hybrid model where some of the many of the features I talked about are available free of charge, with some limits in some cases. But some of them do require a subscription, and I noticed a lot of our subscribers online, so that really appreciate your support, because we do get funding from the agencies at the university. We have a Globus Labs group that does a lot of the core research, and then we productize some of that in the department. But the bulk of the support comes from what's now about 260 or so subscribers. So thank you to all of you that use the service. I hope many of you will engage with us on some of these more interesting capabilities. Like I said, I'm certainly available. I'm just VaaS@UChicago. I don't think I put my email on there, but I'll happily take questions here. And again, I will say we'll be at Supercomputing next week, and I'll be at the Tech Exchange for those that go to Internet to Tech Exchange. And of course, any other venue, I'm happy to engage with you there. So thank you. I'll end there and open it to more questions.
Great. Thank you, Vas. Thank you so much. Any questions out there on the floor? Looks like, yeah, one just popped right there from Carl. Carl, do you just want to ask that question and turn your mic on and say hello?
Sure, yeah, just read it out. Can you comment on best practice for an institution's onboarding one or more entire research teams for institutional access to Globus? And must each team member, for example, apply for access separately? Thanks.
Good question.
Yeah, that's a great question. So no, so the answer is no. Team members don't have to apply to us. So the way that model works is you have a subscription. You can have multiple subscription under the same sort of umbrella for a single institution, and each subscription has one or more individuals who are the administrators of that, and it's really up to you to set policy. So typically, people will request to become members of that. You can proactively add them as groups to those subscriptions. So it's really mostly self-service within the institution once you're onboarded. And different institutions have done it differently. And of course, if users, we do always get requests from researchers saying, hey, I want to use this thing, and then we see, okay, you are at wherever institution, and we know you're a subscriber, so we'll refer you to the respective contact at that institution, but it doesn't require us to be in the loop.
Go ahead, Sean.
Yeah, hi, I'm Sean Matthew from Red Hatch. This is an awesome presentation. Thank you. And it looks really capable. I was wondering if you could just put your 2025 hat on and kind of talk about what's coming down the pipe for your solution. Are the new features that we should be looking for as we plan our internal data projects?
Sure. Yeah, I know some of my product people are probably listening, so I'm going to be careful what I say. No, we try not to sort of sell things forward, but the plans right now, the areas of focus right now are on the compute side. We're certainly building out the multi-user capabilities, and specifically in the area of administration. So providing some type of console, allowing the admins to get greater visibility into what's going on in that environment. On the flow side, and both of those I mentioned earlier, we're making sure that all of those services are usable under the high assurance model, which means that you can use them with protected data, CUI, PHI, PII, and so on. Those are substantial efforts. We're also starting some compliance work. We already comply with some of the NIST standards. But as you know, those are evolving. We've also looked at maybe doing a gap analysis for FedRAMP. So there's a lot of work on the compliance side. We continue to enhance our connectors. So that's the way that we connect to various cloud storage and archival systems. So those are some of the high-level aspects. Of course, there's ongoing incremental work on every aspect of the system, and I don't mean to trivialize that because it's actually quite important. On all of the underlying services, on search, on the auth service, the flow service in other areas as well, make that even easier to consume and define flows and so on. So it's progressing on multiple fronts. We have a massive and growing backlog, and we get a lot of feedback. The nice thing about working in this community, folks are very vocal, and we are very engaged with them because we are you in some sense. We're working at an institution with the same kinds of challenges and requirements. So we understand that, and we get a lot of feedback. So we appreciate that. If you wanted to, Sean, if you wanted to get more detail on that, happy to set up a time and we can get product management folks on the line as well.
Vas, looks like another question came in.
Yeah.
How complicated can the analysis part be
Yeah.
involved?
Yes, I showed something really trivial. Some of the codes that we're running, like in that in this example here, this correlation, I think, runs on a supercomputer, and it's an incredibly complex piece of code. So the answer is it can be arbitrarily complex, very complex. Yeah.
Gotcha.
Can I synchronize a Globus group with an Access project? So if I add an Access ID to the Access project, the Globus ID corresponding can be added. If that is so, yes, you can. So the groups, the group service built into Globus has an API, as do all the other services. So you can programmatically pull a list of members from an Access project, add them to a group, and you can do all sorts of things with their identities in Globus as well as their Access setup. So, but that is something you would have to write yourself. You'd have to write a script to do that and maybe run it periodically. But yes, that's doable through the API. Can you comment on management of distributed denial of service attacks if appropriate? I don't know that I have much to say on that. Honestly, I'm not as close to the details of our operations team. We do have some capabilities in place to throttle requests. So most of the limits on the service are set pretty high, but certainly API call rates and things like that are have lower limits and throttle just to ensure quality of service. So we have had a few cases where on the surface it might have seemed like someone was sort of trying to do some kind of DOS attack, but it actually turned out in both cases that I can think of, it was legitimate users who were calling the API in a way that probably wasn't appropriate. They were actually much more efficient ways of doing what they were trying to do. But I think they were just in the early stages of developing some automated solutions. So they were putting extensive load. I think in both of those cases, we sort of identified that, talked to them, took it offline. I don't know if there have been other cases. That's probably a question better answered by our operations folks.
Right. Well, I think we're at time. Thanks again for coming. Appreciate the presentation here. If you could share that slide deck with me, that would be great. I could post that in our notes, and Martin and I will get that published on the website and get this recording cleaned up and added for others that could not be here, and get that out.